Good evening, kids. Today we're going to discuss what is resistance and what is Ohm's law, right? Resistance is what we call as the restrictions that current will face while going through a conductor. Now, over here, this red object, this red cylinder, uh, is a resistor. It's a conductor in which you can see these black spots are the restrictors which will hinder in the path of the current that will go through this conductor. And we do know that the current flows from the negative to the positive. Over here we have this red symbol which represents conventional current, which is coming from the positive and going to the negative end of the battery, right? So please don't get confused. This is conventional current, not the actual current which comes in blue arrows, right? This is conventional current. Now, what is resistance and what is Ohm's law? Ohm's law states that the increase in voltage results in increase in current. As you can see, the more I increase the value of V, as you can see, this symbol is also changing. The current is also increasing. As you can see, the current, the amount of charges that flow through this conductor are also increasing as I'm increasing the number of batteries, right? I'm adding parallel series voltages to increase the total voltage. I'm going to keep it to 4.5 volts. Now let's see what happens if I increase the resistance. And as you can see, if I reduce the resistance, the restrictions in the path of the current are very less, very few. So very little restriction is there in the path of the current. As soon as I increase the resistance, as you can see here, these black dots are increasing. Hence, the electrons which are flowing through this conductor will have collisions and they will lose some of their energy, which will be turned into heat. By increasing this, the resistance will also heat up. As you can see, if I keep on increasing the resistance, the current is getting smaller and smaller, and hence the value of the current that flows through this conductor is reduced, right? Now, over here we need to look into the factors which affect resistance in a conductor. For that, we're going to go to resistivity simulator. Over here, we have this conductor. Let's say if a standard current is being passed through it, right? How different features of a resistor affects the current that would flow through it, right? How R is defined, right? So over here we have resistivity, which is the innate ability of each independent material. For example, for copper, this is going to be different. For steel, the resistivity value is going to be a little higher. For copper, it's going to be lower because copper is a good conductor. Steel is not a good conductor. If we take water, then it is going to be even less than steel, perhaps, if it's pure water. And if it's salt water, then the resistivity factor is going to be lower. So many features affect the resistance. So over here we are talking about solid resistance. So we have this solid cylinder which is representing a resistance. If we increase the length of the resistor, you can see the number of the black dots in all of the resistor are increasing. So we can say an increase in length of the resistor is going to increase the number of restrictions that the current is going to face while going through this conductor. And if I reduce the length, then you can see lesser number of restrictions are there, hence more current would flow, or the current would flow without any restriction, right? Now, consequently, area affects inversely to the resistance. If I increase the area through which the current is supposed to go, the number of restrictions are increasing, but since the same amount of current is supposed to go through this increased area, so it has more pathways and it would have lesser overall restrictions. Hence the resistance decreases with an increase in the area. And again, yet again, if I increase the length of the conductor, the resistance increases, right? Let's reduce these to a certain value. Yeah. Now the factor of resistivity. Now resistivity, you can say, is the total number of these black particles that each conductor of the same length will have, right? Let's say this is for steel and this is somewhat copper or gold, which are good conductors, very few restrictions. Steel having higher resistance due to more restrictions in its path. Hence, we can say its resistivity is more. So you can play around with this relationship. It will tell you how things affect while you slide these up and down and see what really happens to this, right? I hope some of these confusions regarding the resistance and the factors that affect resistance are clear to you, as well as how the Ohm's law works by increasing the voltages and the current changes that occur in the circuitry, right, through a resistor. I hope things are clear. I'll try to come up with other confusion, points and discuss those in detail. Thank you.